Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level other type of puzzle. And it's called Hexuro number 7, 68 plus or minus 1. And the author is Nell Gwen. And here are the rules. We have hexagonal kakuro, where we need to place a digit from 1 to 9 in each empty cell such that digits do not repeat in an unbroken line with no black hexagons separating them along any of the three directions in which cells share edges. Clues on black hexagons indicate the sum of the digits that clue sees in the indicated direction, up until the next black hexagon or the edge of the grid, whichever it sees first. So we have the digits. Does it say 1 through 9? Yeah, 1 through 9. So in every cell in this grid, we need to place the digits 1 through 9 such that there are no repeats as an extended length of white cells. So you could have repeats along, say, this path here, as long as there are black hexagons in between, right? So you could have repeats here. But for every extended length of white cells in this puzzle, you cannot have repeats. So that means along this diagonal, you can't have repeats. Along this row, you can't have repeats. Along this row, you can't have repeats, etc., etc. And for digits with, it's really hard to read those actually. For digits that are on these hexagonals, the sum of the digits that it sees, which means it does not include anything past a black hexagon or the edge of the grid, it must add up to the digits that are on the hexagonal number. So for example, this has an 8 here, which means along this diagonal here, those two digits must add up to 8, because that's up until the edge of the grid. So you could have something like 2 here and 6 here. That would be potentially possible to add up to 8. And those are all the rules. These are kind of hard to see, so apologies in advance for that. I'm going to have to probably go pretty far forward because it's really hard for me to actually spot this too. Is there a way to make this bigger? Display size. Oh, okay, it does make it bigger. But the problem is that then you guys can't really see it. What about 55? Yeah, I think that's good enough. And I don't have to squint to actually see the numbers myself. Anyways, if you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So, along this diagonal, there are 3 digits adding up to 6. So this is 1, 2, or 3. Ooh, this is going to be hard because I can't. This has to be 1, 2, or 3. Along this row, it adds up to 7 up until the next black hexagon. So it has to be 3 digits adding up to 7 without repeats. So this is 1, 2, and 4. Along this diagonal, it adds up to 25 for 4 digits, and this is 1 or 2. Along this diagonal, it adds up to 10. So this is 192837. This has to add up to 8, so it's 1726 or 35 there. For this is 6 digits adding up to 37. This is 5 digits adding up to 18. So you cannot have a 9 there. 1, 2, 3, 4, 8. Can you not have a... You can't have not have a 1. So 1 has to be somewhere there. Because if you don't have a 1... Okay, let's continue with this. 25. This has to be 1 with either 7, 8, 9 or 2 with 6, 8, 9. So it must be 6, 7, 8, 9 there. This adds up to 10 with this diagonal here. So this must be 1, 2, 3, 4 with that. This can't be 3 because these both are... one of these is guaranteed to be 3, and they both see that hexagon. So therefore this can't be 7 to add up to 10 with that digit there. These add up to 9, so this is 1 through 6 here. It sees these digits, though. It sees both of these, so therefore it can't be 3. It sees both of these, therefore it can't be 4. Can it be 1, 2, 1, 2? It still could be 1, 2, 1, 2, and that's 6. It's 3 digits adding up to 16 here. 6 digits adding up to 37. That means there are 3 digits that are missing, which add up to 45 minus 37. 45 is the sum of the digits 1 through 9. So that means it's 8. Which means it's either missing... It has to be missing 1, 2, 5 or 1, 3, 4. So this can never have a 1 here. This is 3 digits adding up to 20, so this is 3 through 9. This is 2 digits adding up to 16, so it's 7 and 9, because there's no repeat. That eliminates 7 and 9 in that hexagon there. We have 9 here. 6 here. 7 and 9 both see that cell. So 4 cannot be here, because that would force this to be 7 and 9 here, but this can't be 7 or 9. So this can't be 4, this can't be 4. $37 is here again. There's no 1. 26. That's not that restrictive. We have 9 here. Can this actually be 1? 1 would have to be with 2 and 6 or 3 and 5, and neither of those could be there. So this cannot be 1. This could be 2, 3, and 4. That could potentially work. This adds up to 10, so there's no 5. This is 26. That doesn't help us much. Actually, does it? 26 for 6 digits is pretty restrictive. That means the remaining 3 digits that are not in that set must add up to 19. Well, it could be 2, 8, 9, though. 2, 8, 9... 3, 7, 9 cannot be a possibility because we have a 7 or 9 here. It could be 4, 6, 9 missing. So is this guaranteed? Can it have both 7 and 9 in this set of 6? I think the answer might be no. If you have 7, 9, that means... No, it could. You could be missing 5, 6, and 8. Which is 19. Okay, again, 37, we have 2 through 9 available. This adds up to 36, which means we're missing 1 and 8, or 2, 7, or 3, 6, or 4, 5. Oh, this adds up to 14, so it's either 5, 9, or 6, 8 here. We have all the digits here remaining. That's interesting. So those are a full set of 9. We have a full set of 9 here. 4, 5, 6, 7, 8 there. This is a full set of 9. Full set of 9 here. This is only 7. Full set of 9. Full set of 9. Full set of 9. This is only 8. 2, 3, 4, 5, 6, 7, 8. That's only 8 also. This is 7. Hmm. What else do we have? Okay. Not that restrictive right now. We do know this has to have 9 and 8 in these 3 cells. So it could be 6, 1, 2, 1, 2. Huh. It could be 5, 3, and... Okay, so what are the possibilities? 2, 3, 4. Which would make that 2. You'd have 6, 8, and 9 then, there. That seems fine. 2, 3, 4 would make this 1, that 2. Oh, then that would be 1, and that's not possible. So again, if we have 2, 3, and 4, this can't be 3 or 4, it can't be 2, so they would both be 1s, but then you have 1 repeated in this diagonal. So this cannot be 2. What about 1, 3? So this can never be 4. This is 5 or 6 adding up to 9. So it's either 1, 3, 5 or 1, 2, 6. So this can't be 4, which means this is a 4 here. So this is 4, which eliminates 4 being here. That means this can't be 6. This 1 or 2 must be this cell here. So these 1 and 2s both see this cell. So this cannot be 1 or 2 here. So this must be 3. That makes this 3, which means this can't be 3. This is 3, 5, and 1 to add up to 9, which makes this 2, which makes that 1, which makes that 2 and 8. So there's no 7 or 8 here. It's 6, 2, 6, 9, 6, 8, 9 with 2, adding up to 25. 5 eliminates 5 and 9 here to add up to 14. It's 6 and 8. 8 eliminates 8 here. So that's 6, which makes that 8. 6 eliminates 6 here. That's 9, which makes that 6. Okay, 9 can't be here, so this is 7 and 9. No 7 or 9 here. No 9 here. So this must be to add up to 20. No 9, which eliminates 3, 8, 9, 4, 7, 9, 5, 6, 9. It's 5, 7, 8 left, and this cannot be 7. So this must be 7 here. This becomes a 5, 8 pair. Five, 8 with 7, adding up to 20. That eliminates 5, 8 from being here. This can't be 7 here. There's no 7 here. No 9 here because of 9 in the row. This can't be 7 or 9. Since this can't be 7 or 9, this can't be 1 or 3, correspondingly to add up to 10. 9 eliminates 9 in the rest of this row. Therefore, this can't be 1. Okay. This can't be 9 because of this remaining digits in this row. There are no 5, 6, 8, or 9. The remaining digits in this row are 2, 3, 4, 7, 9. This is 2, 3, or 4. Interesting. So if we're missing 3 and 4, 1, 3, and 4 in this column, that means this is 2. If we're missing 1, 2, 5, this could be 3 or 4. So 2, if this is 2, 5, 6, 7, 8, 9, to add up to 37, this is the 2, which means 2 cannot appear anywhere else on this diagonal. Remaining digits on this diagonal is 1, 2, 3, 7, 9. And this can't be 7 or 9 because of 7, 9 in the row. This adds up to 26 with a 9. So I think that has to be 1, 2, 3, no, 26. Yes, no, 17. 17. Can you have an 8 then? No. 1, 2, 3, 4, 8 at minimum adds up to 18. 18 plus 9 is 27, which is too large. So this cannot be 8. This has to be 5. So this is 5. That makes this 8, which eliminates 8 in the rest of the row here. This can't be 5 anymore. No 8 here means no 2 here. This can no longer have an 8 here because 5 and, again, 8 with 1, 2, 3, 4, and 9 adds up to at minimum 27. We have 5 and 9, which is 14, which means the other 4 digits must add up to 26 minus 14, which is 12. Well, without a 5, it must be 1, 2, 3, 6. So this has to be 6 here. So this is not 4, 7. This is 6, which makes this 4. This can't be 4, 6, or 7, so it's 3, which makes this a 1, 2 pair here. That means this can't be 3 or 4. This is 5 or 6. We have a 3 here. So the ones missing here then must be 1, 2, and 5. So this can't be 5. This is 6. This can't be 2 or 3. It's 4. So no 3, 4, or 6 remaining. Or 5. So no 3, 4, 5, 6. This is 7, 8, 9 as a triplet. To add up with 3, 4, and 6 to add up to 37. 24 plus 6 is 30. Plus 3 and 4 is 7. So that means this cannot be 4 here. In the rest of this row. 3 cannot be here because of 3 in the column. Remaining digits of this row here are 1, 2, 3, and 5. But this cannot be 1 or 2 because we have both different 1, 2s here. So this is 3 or 5. This is 4 and 6 adding up to 10. 1, 2, 3, 5, 6, and 9 adding up to 26. 6 eliminates 6 in this column here. Okay. This adds up to 21, and we have a guaranteed 7, a guaranteed 8 or 9. Well, you can't have 7 and 9. That means it's 16. 21 minus 16 is 5, and 3 unique digits can never add up to 5. So this must be 7 and 8. Oops, I don't know what I did. 7 and 8, which makes this 7, which makes that 9. So this 3 digits add up to 21 minus 15, which is 6. And that has to be 1, 2, 3. Whoops. So this cannot be 1 or 2 because of the 1, 2 pair that sees this cell. So this is 3. This can't, this is 1 or 2. And this is 1 or 2. That eliminates 1 and 2 in the rest of these diagonals. So no 1, 2 here, no 2 here, no 2 here, no 1, 2 here. These can't be 7. 3 cannot be here or here. No 7 here because of 7 on the diagonal. Okay, 3, 3, 3 could be there. This adds up to 18, and it's 4 other unique digits. So 18 minus 7 is 11. The only 4 digits which can add up to 18 is 1, 2, 3, and 5, which eliminates 4, 6, and 8. So this is 3 or 5. We have a 3, 5, 3, 5 pair along this diagonal that eliminates 3 and 5 in the rest of the diagonal. This can't be 3, it's 9. That eliminates 9 from here. We have a 2, 7, 2, 7 pair on this row. This can't be 2 or 7 or 9. Therefore, this must be 3, which eliminates 3 from being here. 3 also eliminates 3 from being there. This 3 eliminates 3 from being here, so this is 5, which means none of these can be 5. This is 1, 2, and 3. 1 and 2 eliminate 1 and 2 here, so this is 3, which means this can't be 3, this can't be 3, it's 1 or 2. Okay. We have 1, 2, 1, 2 as a pair here, which eliminates 1, 2 the rest of the row, or the diagonal. This can't be 1 or 2. This is 7. This can't be 1 or 2. We have 3, 5, 3, 5 as a pair here, which eliminates 3, 5 in the rest of the diagonal. So this is 1, 2 as a pair. This is 7, which means this can't be 7. That's 2, which makes this 1, which makes that 2, which makes that 1, which makes that 2. Okay. No 1 or 2 here because of the 1, 2 along the diagonal. So we have a 7, 9, 7, 9 pair along this diagonal here, which eliminates 7, 9 on the rest, along the rest of the diagonal. So this can't be 7 or 9. No 7, 9 there. Okay. 2, 3, 5. This 2 eliminates 2 here, so that's 1, which makes this 2. 1 and 2 here. Okay, so the rest of this diagonal has to be 4, 5, 6, 7, 9. Okay. This can't be 6 or 7 because of 6 or 7 along that diagonal there. No 6 or 9 here because of 6 or 9 on that diagonal there. Okay. This digit cannot be 1, 2, 3, 4, 6, or 9. So this is 5, 7, or 8 there. This could be many things. Remaining digits along this diagonal here. Well, let's go this diagonal. We have 4, 6, 7, 8, 9. So no 6 or 9 here. This sees both 7 and 9s here, so this cannot be 7 or 9. And these, we don't really have a restriction here. These add up to 16. We don't really have any restrictions there either. These 7 9s both see this cell, so it cannot be 7 or 9. Okay. We have 8 cells only here, so we don't have any real restrictions there. 5 eliminates 5 here, so that's 3, which makes this 5. That eliminates 5 in the rest of the row. This 9 eliminates 9 here, so that's 7, which makes that 9. No 7 along this diagonal here then. No 9 along this diagonal. 5 eliminates 5 here, so this can't be 3 correspondingly. We know 9 is one of these two. We're not sure which. 26 is not that restrictive. Remaining digits here. No 1, 2, 3, 5. So it's 4, 6, or 8. No 4 here because of 4 in that diagonal. This is 4, 6, 7, or 8 there. Oh, this adds up to 36 for 7 digits. That means we're missing 2 digits adding up to 9. We cannot be missing 3 and 6. We cannot be missing 2 and 7. So we're missing either 1 and 8 or 4 and 5. What are the remaining digits in this row then? 1, 2, 4, 5, 6, and 8. This cannot be 1 or 6. There's no 1, 2, or 6 there. No 4 here. Okay. We are guaranteed one of these is a 2. Because we're not missing 2 and 7. We're guaranteed one of these 2 is a 6. Because we cannot be missing a 6 there. This can't be 8. If it were 8, that means we'd have to have a 1 here to add up to, because 4 and 5 would be missing. But then 1 can't be any of these cells. So this cannot be 8. So that's not too helpful either. Oh, 5 eliminates 5 here. So then this is 4. Okay, which means this cannot be 4 or 5. It's 8. Which means that we are missing 4 and 5 in this run of digits to add up to 9. So this must be 1. This is 2, and we have a 6 here. Right? So we're missing 4 and 5, which adds up to 9. 45 minus 36 is 9. 2 eliminates 2 here. So no 2, no 2. 1 eliminates 1 here, so therefore that's 2, which makes this 1. 2 eliminates 2 in this row, which means this can't be 6. 4 eliminates 4 in the rest of the row. This can't be 4 or 6. It's 5 or 7 as a pair. This adds up to 26. Does that help? Not particularly. Okay, this digit cannot be 1, 2, 4, 5, 6, 7, 8. So this is 3 or 9. Okay. This digit cannot be 1, 2, 6, or 9. So this is 3, 4, 5, 7, 8. Cannot be 8, cannot be 5 because of the 5 here, the 8 here. 5 and 7 both see that's... Okay, well, that doesn't help. This adds up to 16. Okay, if this is 9, 5, 2, and 9 add up to 16. But we can't have a 2 here because 2 on this diagonal. And 7 and 9 already add up to 16, therefore this cannot be 9. Where is 9 on this diagonal? It has to be here, so that's 9. You could have 8, 7, and 1 there. Oh, this adds up to 26 with a 9. So that means the remaining 4 digits add up to 26 minus 9, which is 17. That's not that restrictive. Okay. Okay, so this is done. 4 and 6, this is done. 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 So is this and this. This is done. This is done. This is done. This is done. We just have this, this, and these 3 left. And this 5. Okay. One of these is 6. So what are the digits that can be here? 1, 7, 8 works. 3, 7, 6 works. 2 obviously can't be here. What about 4? 4 does not work. This has to add up to an even sum. This is an even number here. So to add up to an even sum, this is odd, so this must be odd. We can't have 5. Can we have 7 here? If we try to have 7 here, that would be 7, 5, and 4, but that does work. So this could be 7 there. 9 obviously can't be there. So this is 1, 3, and 7. Not that restrictive. Okay. This can't be 6 because one of these 2 is a 6. No 2 here, so this is 1, 3, 4, 5, 7, 8, 9. How about here? This can't be 2 or 9, but it could be a lot of other things. So 1, 3, 4, 5, 6, 7, 8. Those are all the possibilities, which is a lot. Okay. This has to be 5 through 9. No 9 here because of 9 on this diagonal here. This can't be 1, 2, 3, or 4. This 8 eliminates 8 here. Aha. So then this is 4. There's no 4 here. Okay, that does restrict things a lot. So the 6, 8 pair eliminates 6 and 8 in the rest of this cell. 4 eliminates 4 in the rest of the region here. This can no longer be 7. That means the minimum of this would be 7 plus 5 plus 6, which is 18. So this is 1, 3 as a pair, which eliminates 1, 3 in the rest of the diagonal. So this can't be 1 or 3. We have 1, 7, 8, or 3, 6, 7, or 3, 5, 8. All of those work. Huh. Okay. Hmm. Um. Hmm. How does that work? This doesn't have anything with it. Can you have 9 here? 9 plus 4 plus 6 at minimum adds up to 19. So no, you cannot have 9 here. You could have 7. Can you have 1? No, 1 would require 8 and 8, and that doesn't work. So this is 3, 4, 5, or 7 here. Okay. Um... Okay. Um... Hmm. Um... Oh, this 9 eliminates 9 here. That's good. So therefore this is 3, which eliminates 3 here, so it's 1 and 3 there. That helps a lot. This cannot be 1, which means this can't be 7. 3 eliminates 3 here, so this can't be 5 to add up to 8. 3, either 5, 8, adding up to 16, or 3, 6, 7 adds up to 16. So either of those still work. This 3 eliminates 3 from being here. We have a 4, 5, 6, 7, 8 quintuplet in this row. That leaves this as a 9. So that's 9 here. 1 eliminates 1 here, so that's 3, which eliminates 3 here. It's 7, which eliminates 7 here, so it's 5, which eliminates 5 here, so it's 7. So this must be 3, 7, and 6 to add up to 16, which makes this an 8. There's no 8 or 7 here. No 5 here. 6 eliminates 6 here. So this is 7 and 1, adding up to 8. 7 eliminates 7 here. This can't be 7, so this is 4. This can't be 4, 6, or 7, therefore it's 8, which makes this 6. 4, 8, and 5 add up to 17. 3, 5, 7, 9 adds up to, I think it's 24? Yeah, 3 and 9 add up to 12 times 2 is 24, plus 2 is 26. That means this can't be 5 or 7. This is 8. This can't be 8. So it's 5 or 6. Remaining digits in this row are 2, 4, and 6. This can't be 2 or 4. So that makes that 6. This can't be 2 here. So that's 4, which makes that 2. 6 eliminates 6 here. So that's a 5. And that's the solution. Yeah, I like these Hexuro puzzles. I've done a lot of Killer Cage Sudoku, so a lot of these are very unintuitive for me. So I can spot these things pretty quickly. and I know what these sums could potentially be and where to sort of target these things. The Hexuro part though is very interesting because it's hard to spot necessarily the diagonals. The rows are a little bit easier to spot, but the diagonals can be challenging at times. So anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.